for remote participants?
We can hear you remotely.
Great, and we can hear you.
Ja, ich hatte, das Trusting Meeting morgen. Ich glaube, ich hatte in so einer Maske wieder so festgebunden, so eine Leiche. Und als ich dann unten ankam, war die weg. Und ja, saß schon Malcolm und so, die saßen dann mit Maske rum. Und dann musste ich also betteln, dass mir jemand eine Maske gibt.
All right, we'll give a few more minutes for everybody to trickle in, but what?
The session on the first session of the day, or you have two sessions?
No, the first session of the day. Sorry. Yes, no, we are not that busy.
What's not in my calendar?
Yeah, no, we are. Yes. But in the meantime, anybody, while we're waiting for people to trickle in, does anybody want to volunteer to take notes?
No, I'm not going to take notes.
Everybody looks assiduously at their laptops. Good morning. All right. I think people are beginning to find this room on the far end of the labyrinth here. So I will ask again if anybody wants to take notes so we can get started.
No.
I heard a no from the room.
Next year.
Next year. Okay.
Maybe.
Yes, you've done it a lot, Stefan. I think I knew a lot. Let's see. Magnus?
Yeah, I can do it.
Okay, thank you. All right, so let's go here. Session notes. The session is being recorded. Please, if you're in the room, please sign in to the Medico Lite client. which you can do either from the QR code on the screen or from the agenda. That gets you on the blue sheets. It also lets you join the mic queue for using the virtual mic. If you're using the full client, please keep audio and video off, and wear a mask except when speaking, and even if you choose while speaking. Remote participants, please keep audio and video off unless you're actually speaking. For remote participants, here's the tips on how to use the Metaco client. Remember, you need to actually enable your audio when called on. You can turn on your video if you want. It's helpful, but you have to turn on the audio separately, or we'll see you but not hear you, which is usually not that useful. Here are some links. Note well, you've all had to click through this to be here, but just in case, reminder of everything. The code of conduct and the various IPR policies. Emphasizing particularly the code of conduct. Please, if you are aware of any problems along these lines, please either contact me if this is related to this working group or the ombuds team. Mask policy, please wear your mask when in meeting rooms, except when actively eating and drinking or speaking at the microphone. If you need a mask, I think everybody here has a mask, but if you need a mask, we have some up here. If your mask breaks or something. Here are the notes on this. Chairs are me and Bernard. Bernard is remote today. I'll keep an eye on the chat, but if other people can, in case I'm distracted, that'd be good. And we have Magnus taking notes. Bernard, if you have anything you want to say at any point, jump in. I see you on the unmuted, but I do not hear you, Bernard.
Yeah, I nothing much to report.
Okay. Here's our agenda. If anybody has any comments on anything they'd like to tweak or change or add, speak, let us know. Speak now or interrupt as we go. This is roughly what we'll be doing. Draft status, publish some drafts. We have some things in RFC editor. We have one thing in misref. Frame marking. Mo, we still need that revised draft for that. Mo is nodding, so just a reminder to Mo. Working group, the working last call. We completed the skip draft. There was a revised draft on, based on the various directorate and the like and reviews. Reviewers have been contacted to make sure they like the changes. 7983 BIS did this working group last call. That's on me to do the write-up, which I'm sorry I didn't get to yet. I will try to do that soon. We've adopted RTP over Quick and EVC. There was a call for adoption game state over RTP. There were hardly any. There were only 2 responses, one of which was from a coworker of the proponent. So we didn't feel like that was terribly exciting. Colin, do you wish to speak? Are you still interested in doing this? And can you get?
I mean, it's moving to multiple, companies sort of looking at this and using it at this point. And I mean, I think the most interesting comment really is that, like, the part of negotiating the defining the media container, sure, this working group would be happy to do it if there was a document done somewhere that's like here's the format itself. Yeah. But doing the format in this working group, I believe, is within our charter technically, but is of no interest whatsoever to anyone in this working group. It's completely independent from anything that's done. So dispatch sent me here. Here has not really rejected me to go back to dispatch and say, I can't do this here. Yeah. But it never made sense for it. I didn't think it should be done here. Okay. And so I'm not sad about that. And I agree with the, Suhas and his sock puppet Fluffy both like this is sort of irrelevant. But so I'm not denying the response. There was also no responses against it, I'll point out, basically.
Yeah, no, but basically, I think But
it's that there's not strong interest or strong expertise in defining a game format in this working group is true, right? Yeah. So, I mean, what do you think you should, as a chair, what's your advice to me? I'm trying to bring some new work that is actually sort of relevant to the IETF. What do you tell me to do?
I mean, I think the issue is more the expertise than the interest. I don't know anything about game states. I couldn't tell you if we get it right or not. And I don't think very many people in this room have that expertise either. So if you can find the people who do have the expertise and say, are you willing to participate in this working group for, however long it takes to do this work, then, and they're interested in it, then,
okay, let me flip that differently on it. Is what's the harm if we get it wrong, right? I mean, zero.
I guess. I mean,
Yet another
one of the reasons why this doesn't
draft to add to the pile.
Yeah. So look, I'm not really sure what to do with it next, but I feel a little bit like I've been bounced around. It's been a year now, and no one has a location at IETF that could possibly do this work. And that's not your fault. It's not this working group's fault, but it is the reality of what's going on.
Yeah.
No, this is very much the IETF's job, right? Okay.
I will get it to the queue.
So David Skenazy, Internet Architecture Board. So I have not read the draft, but just from a high level, I want to start with a clarification question for Colin. What is the benefit for you in having this as an RFC as opposed to a blog post, a wiki page, whatever?
We need the IANA registries for an extensible mechanism that multiple vendors can add what they need into it. That's what we really need. It's an extensibility mechanism for multi-vendor work.
I see. So you need it's not an existing code point in an existing, or a new code point in an existing registry. You want a new registry.
Right.
Okay. So then often for things like this, an independent stream RFC can create an IANA registry, and that might be an option for you, because it sounds like what you're not asking for people who understand this to review and provide feedback, because the expertise maybe isn't here. You're just asking for a stamp so you don't have to run an IANA registry, which I totally get. That's valid. So I would suggest making that an independent stream RFC. And I saw Elliot, he's here in person. So the AD is coming. I'm running away.
Yeah, I think other SDOs can create a registry. I think he's right on this. Yeah.
I can check. I'll check.
Stefan?
Actually, I have an example.
So I would gladly yield to the area director, of course, but since he goes away, I was grumbling here in the corner saying this is not the IETF's business, and I continue to believe this is not the IETF's business. If we define making the internet better or whatever as basically encompassing everything that can be coded into bits and being sent over a wire or wireless to some other place using a protocol roughly like IP, then of course it's the IETF's business. But I think this is a classical example of an coding technology, even if it's mostly metadata-ish type of stuff, and that should go to committees who know what they are doing in this field, and that would be MPEG, that would be AOM, that would be those places, and not here. Yeah, we have the vast majority of the people running around here don't understand this stuff nor care about it. Thank you.
So I would like to reply to Stefan on this though, but Stefan, you said exactly those same words when we said we wanted to do an audio codec in IETF called Opus. It is now the most used codec in the internet. You said exactly those same words when we wanted to publish AV1, which is one of the most, not AV1, VP8, which we did through independent stream back to the recommendation to me. It's one of the most used video codecs. And AOM has no interest in doing this game type move data. It's very different than the type of other work they do. This is totally the wrong place to do it. MPEG has no interest in this type of minimal compression. We've discussed that. This is more like a JSON format. You could maybe say W3C should do this, or the Open Spatial Consortium or something like that. But those places that you recommend, they're not practical.
So may I respond to that?
Sure, go ahead.
Okay, thank you. And so, I go to these MPEG meetings as an example. I haven't seen you guys going there and proposing anything like that. So don't say they're not interested, because I wouldn't know. I'm also going to AOM, also quite often, and I mean, you go there to the calls, right? I haven't seen a Cisco initiative over there either. So don't say they are not interested. I don't think you know, right? Or if you know, then at least it wasn't publicized in any significant way. I agree that Opus was a success. I disagree that it was an IETF success. It was a success of a handful of people who used the IETF as a venue. All the others, I don't even want to go there. But Opus was not the classical collaborative effort of creating a protocol. It was just a handful of people who were talking to each other anyway, all the time. So I still wouldn't want to see this organization becoming an organization that steps on other people's turf without need, really. Thank you.
Bernard, you're in the queue, I see.
Hi, Cullen. Harold may be about to say the same thing, but I recall having a discussion in the W3C about the game state API, and what to do with it, how to send stuff over the network from that API. So you may have something there, Cullen, about the W3C, and they have had game-related workshops before. So that might be one way to find some of these people. Just a thought.
Harold?
Harald Alvestrand. The problem here is really that this group has set itself up as a gatekeeper for registration of RTP formats. We now have a need for something to pass that gate. So the alternatives for this group are basically lead, follow, or get the hell out of the way. So where the technical details of this proposal needs to be discussed, well, any group consists of 10 people, no matter how many people who are in it. That's another question. But if this group is a gatekeeper for registering stuff that needs RTP payloads, well, this group needs to accept that it either needs to lead, follow, or get the hell out of the way.
Sergio, you're up next. You're muted, Sergio. Yeah, I think you clicked to share slides, not to share video. Okay, Sergio says he'll fix his audio and ask for Q again. I'll take you. All right, Stefan?
So in direct response to Harold, I tend to agree, and I have agreed that the payload format in this email that's cited there, I have agreed that the payload format itself is, in my opinion, clearly within the charter of this group, and I wouldn't at all stand in the way of doing that. However, there is a format, a media format, defined in the same specification, and that simply shouldn't be done here. So if that were done somewhere else, in parallel or sequentially, I don't care, right? I wouldn't stand here. Yeah, it's the problem is that this is a document that does what traditionally has been done in two different documents, one being the actual media technology, the other being the payload format, including the registry. And that obviously is well within the charter here, and go for it. No trouble with that. Thank you.
Magnus?
Magnus Westlund. Yeah, I'll react to Harald's here about the gatekeeping when it comes to RTP payload formats. I would note that, first of all, as Stefan said, it's the format versus the RTP payload format for the two different aspects here. And the second one is that actually any RTP, the only thing you need to register a code points for RTP payload formats is a stable specification. You don't need to go through this group at all. But that's, I mean, we encourage it. We have the expertise and we want to provide input, etc., about that proposal. So that's, I mean, I just want to temper Harald there a little bit. So, but I understand the struggle here to actually define a format when you have a hard time finding a body. But
Mo?
Mo Zanatti, I don't think this is just about registration. I think we really need to figure out if there's a good venue to have the discussions for this kind of thing, because it's not just, you know, let Colin publish something that only Colin's going to use. The core aspect of this is, you know, describing things in, there's two main aspects: describing, you know, meshes or geometrical structures efficiently. And I agree with Stefan that that's the purview of other groups, and there are you know, other groups actively working on this, but their scope is worlds, not you know, small telemetry. So they're going to be biased towards, you know, something that's, you know, very compact and efficient for a very, very large object, you know, mesh compression for an entire world, not for 5 points or something like that. So the other aspect of this is it's also more like, you know, telemetry or real-time input. And we've seen other requests in like media over quick about use cases like remote desktop and things like that. How is, you know, input, whether it's, you know, human input or some other form of input, going to be carried over RTP? And this is just one specific type of input. This is, you know, polygonal mesh input. But how you encode input in general and how you describe it is, you know, is also, you know, something that needs to be discussed. And so I don't think that it's just, let's just register something and get it out there and nobody else will ever use it. I think we need to really think about how do we describe, you know, simple geometries, and how do we also describe input, and where's the right place to have conversations about those two things. And there is work at AOM and MPEG on polygonal mesh compression. But like I said, it's for compressing worlds, not, you know, not I move my hand an inch this way.
David?
David Skenazy, just wanted to react to what Harold was saying. So forgive me, I wouldn't consider myself an AVT core enthusiast. I'm very new to this space, and I just was kind of walking by in the hallway. But I know how IENA works. I was looking through the RTP registries, and all of them have a registration procedure of expert review or specification required. And specification required means expert review, and the expert has verified that there is some kind of a spec. The spec could be written on the back of a paper napkin that you've taken a picture on and posted on your website. That's fine. It is actually the specification does not have to be an IETF specification. No, yeah, exactly. Like if I promise that I will keep serving that picture forever on that URL. Anyway, like that's the expert's purview, but that does not mean that you need any like a standards track RFC. It doesn't mean you need any kind of RFC. Like the simplest way is a draft 00. Like that is definitely accepted as a stable reference. They stay on the archive. So this group is not actually a gatekeeper to any of these registries. And similarly, this group is not a gatekeeper to create a new registry. So I think as someone who's done something like this before, the two options here is tell Cullen, like, sure, we're interested, we want to work on this, let's do it here, or we're not interested, just go publish it on the independent stream, you get everything you want, and win-win-win. So like the only way you can block is if you think, okay, this is so harmful that we want to use the INR registry as a way to tell Cullen, no, 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 bad, bad, bad. But I don't think that's the case here. People are just saying, meh, shrug. So I think there's a clear path forward here, and Cullen, like, does that work for you? I'm trying to help, but yeah.
Bernard?
Yeah, I think we should close the line, but yeah, to follow up on what David just said, I think the question is, Cullen, what IANA policy would you want? And, you know, who, if it's expert review required, who would the expert be? Do you have a volunteer in mind? And how do you want this to work? I wouldn't worry about the working group or getting it published. Just think about how you want to set it up. Do you have any comments?
Yeah, it's the small numbers are expert review. Any expert would be fine, and the larger numbers are first come, first serve. So it's pretty clear and pretty simple how the IANA registry would work on it.
Yeah, so actually, you really don't need that much expertise in the working group. All you need is a document that creates the registry with it kind of will self-function on its own once you do that, right? With the expert review and the IANA policies.
Yeah, correct.
Right.
So the struggle that I get myself to here is dispatch sort of sent me here. So on the where to do it and how to move forward, right? I mean, if people like, if the group wanted to recommend, Cullen, we recommend you do this through the independent stream, like that would be great. I'd have no problem with that. That'd be super. What I don't want to do is go do it through the independent stream, have it go to the ISG review, and have them tell me this is clearly in the scope of this working group, because it is in the scope of this working group's charter, which is a valid reason for the ISG to block the independent stream from publishing this document. I do not want to do that. So you guys have to tell me in the minutes that you're recommending I take it to the independent stream, or I'm not taking it there.
Yeah, let's take it to the. Yeah.
Okay, is there anybody? Does anybody object to telling Cullen, take this in the independent stream, and this group has no problem with publishing it as an independent stream? Hearing no objection, let's put that in the minutes so that if anybody at the IESG complains, you can point them at these minutes.
I can hear you.
Hey, yes, but you know, but we don't know how long this will take. Maybe you won't be still on the IESG at that point. Yeah, I hope it doesn't take that long either. But yes, yeah. Okay, so that is. Murray is going to. Did you want to say something, or are you? Nope. Okay. All right. All right. Well, we're good. That is taken care of, and Cullen knows what to do. Cullen wants to say something more.
I just want to say thank you. That's all.
Okay. Okay. Welcome. All right. All right. Much less controversial. We had a CFA on the RTP payload for V3C. We had several affirmative responses saying we'd like to do it, so I think the conclusion is we're going to adopt that. Bernard, is that, I think you were running that, so do you want to confirm that?
Yeah, I mean, it looks to me like there's consensus to adopt. Are there any objections in this room? If not, then the author should just submit a draft IETF AVT core doc.
Sounds good. All right, we are still have a CFA going on the RTCP messages for green metadata. The draft is available. That's going till November 30th. If you have any opinions on that, please comment on the list. Or if you have something you need to say here about it, let us know, but that seems only if it's, urgent. Okay, and next up is RTP for Skip. Okay, there you are. Go ahead.
Here I am. Good morning. So we'll go through pretty quickly here. There's not a whole lot to report, but we did submit the revision 03 draft in next slide on October 17th, responding directly to reviewers' questions. Again, revised the abstract introduction and mapping to STP sections, submitted it as an XML file. I think we've resolved this issue before. It keeps coming up in all these reviewers, whether the SCIF 210 reference is a normative or informative reference. I don't know if we need to bring that issue up again or not, or just, I think the group has decided it's, again,
Colin is going to the mic despite not using the queue. Or he's using the queue after.
I'll just add myself. I think it is really important that remains an informative reference, and not necessarily for this specification, but in general, because we've gone through this whole argument before, and the reason why is it gets you out of a it means that if there is, I'm not talking about SCIP, I'm talking about some other codecs. If there was IPR on the codec, there's not necessarily IPR on this. And I think that's I think that should be a fundamental policy. I just think it should be a thing that we update in our guidelines for authors of this media formats, is that it's an informal reference.
Okay. All right. And so I guess really the next step, I guess, is I know that the last reviews were done on the 02 version of the draft. Most of them were ready with issues, I guess. More so, next slide, just to talk about what to do about requesting another formal review to have all the reviewers be satisfied with the current state of the document and allowing it to go forward.
Did they respond to you in each case? I don't know that they need to re-review it. Just basically what I want is just a citation from these people saying, yeah, I'm fine, and you address my comments. That's all.
Right. No, I've not received any. We've not received any feedback on the version 3 draft at this point. So,
well, so none of the reviewers responded back to you, or
not regarding the version 3 document. No.
Okay. Well, there's this. I think you've done what you needed to do. You asked them, and if they're not responding, I don't know that there's anything more you can do. You can't go to their house and make them do it.
I can reach out to them once again,
just maybe send one last message, and then that's it. We can't haggle them forever.
Right.
Okay.
Yeah, so that's basically where we're at this point, I guess. What to do to resolve any of the.
Something to say? Okay. All right. And that's all. That's the only slides you have. All right. So, Stefan.
On the subject, and this is not at all going toward Daniel here. I've noticed recently, over the last 3 years or so, a real increase in bureaucracy. You have to sign this off, and the sign off has to be recorded. And can we cut down a little bit on that, please? It's getting, frankly, really annoying. And this is. We're not that close from ISO style sign-off procedures now. Thank you.
Yeah. Well, that is a good point, Stefan. The amount of questions you now have to the size of the pub rec questions has kind of grown enormously just in the last 6 months. So I think those sentiments are good ones. But for this purpose, I think we've gone through enough hoops to write the pub rec. So well, if hassling is required for the directorates, they'll be hassled later in the process. But I think you've done what you needed to do, Dan. So.
All right. Thank you.
Okay. All right, so I think we're good there. Bernard is the shepherd on that, so.
Yeah.
All right.
Okay.
And Bernard, you're talking next.
Yeah. So at the interim meeting, we basically talked about a little sandbox where we could experiment with RTP over quick in JavaScript. So next slide. There were some curious observations. A few things were that, first of all, the glass-to-glass latency was considerably higher than the measured frame RTT, and there was noticeable lag when you went to high resolutions like full HD at 30 frames and a megabit average target. I was measuring like 630 millisecond glass-to-glass latency with an frame RTT of 100 milliseconds. So that was a little curious. The other thing that was weird was that we didn't observe any reordering on the receiver. I think in hundreds of tests, no reordering at all. So that raised a bunch of questions about what was going on exactly, why it wasn't why we didn't see reordering. And also the bandwidth consumption was considerably lower than the average target bit rate, except for a weird VP9 bug where with variable bit rate and temporal scalability with 3 layers, it sent like at 10 times more than the target average bit rate. So the question is, what was going on? And next slide. We, I think, finally figured it out, which was basically that you have to be very careful in the way you write in the Web Transport API. In particular, it is not recommended to await writer.write because that promise returns once a chunk is handed off to the quick send queue, and that effectively prevents the quick stack from multiplexing frames or streams on Web Transport. And so you suppress the concurrent sending of P frames and I frames. And that's why the reordering was rarely observed on the receiver, because basically you were sending the iframe, waiting until it was essentially almost sent, and then sending the next P frame. And that also reduced the bandwidth usage by stretching out the delivery times. So the way to fix that is you only await a writer.ready promise, which happens as soon as you can send on the stream. And then you just write the chunk, and then you call writer.close and .then for whatever you do once it's closed. So once you do that, the P frames and I frames get sent concurrently. I'll show you some graphs, but it also looks like this results in more rapid congestion window growth, so that your iframe actually gets sent with fewer RTTs, which is kind of interesting. We did start observing reordering at the receiver, so we had to do a reorder buffer. The jitter buffer is actually implemented in another API. It seems like the smoothing is now occurring also. The video looks a lot smoother, and that's occurring in the media stream track generator API. So that's kind of interesting. Between this reorder buffer and that smoothing, you seem to get the effect of a jitter buffer without doing hardly any work. And then also the bandwidth consumption is now closer to, but slightly larger than the average target bit rate. And the glass-to-glass latency is considerably lower. It's hundreds of milliseconds lower now. And particularly, you can run now the demo at high resolutions with complex codecs like AV1, and it's close to near real-time performance. So that actually is pretty good news for things like ingestion, video ingestion, or potentially distribution scenarios, because it seems to work pretty darn well. Anyway, there's a good reference which talks about some of the nasty effects of a sync await in JavaScript and some of the things that can happen. I'm going to go through the rest of the code and see if there are any more things like this. Anyway, next slide. So this is an example of comparison of before and after. And if you click on the before, you'll get the code that runs with before removing these bottlenecks, and then after you'll see what happens afterwards. But one of the interesting things in the after is it does look much closely clustered around the RTT min for the P frames, and then the large frame at around 11,000 bytes is probably the I frame. And the other thing you can see is the combination of well, there's basically minimal extra delay above the transmission line, which kind of indicates that by this point, the C wind has grown to be able to send these 11,000 bytes in one RTT. So anyway, the bottom line of all of this is that it's very possible to do interactive. The performance of RTP over QUIC can potentially be extremely good without even a lot of effort done. This is entirely in JavaScript, no WASM or anything like this. So it looks like you can get interactive performance out of this without a lot of effort. Anyway, that's the update. Oh, and here are some pointers if you want to learn more about about this stuff. Pointers to the code for the optimized version, the old version, so you can see the comparison. And also, there's a web codecs only demo which has no transport at all. And at this point, the one with network transport is pretty close to the performance of the no transport demo. So.
All right. Thank you, Bernard. Any questions on this? No, we'll move on to Peter. Peter, are you here? There you are. Good.
Test, test, test.
Yes, we hear you.
Great.
Go ahead.
Okay, so this is talking about issue 29 on GitHub. Next slide.
Oh, and hold on. Martin Thompson has from the room. I was just giving notice about the talk. Why were the S-frame sheriffs not aware of this? He's in another room a long way away.
I don't know.
I don't know either. I'm sorry. Okay, go ahead.
All right, so I'll try to describe the scenario. Next slide. Just reviewing simple things. RTP over QUIC allows you to have big RTP packets, perhaps a whole frame in one RTP packet in one QUIC stream. Next slide. And S-frame lets you encrypt the media. Next slide. So if you do S-frame over RTP over QUIC, you put a video frame in an S-frame and a QUIC stream, and you get a big RTP packet with an S-frame payload, which is opaque because it's encrypted. Next slide. So what's the problem? Described in the issue. Next slide. It is that what it says in section 4.1 of the RTP over QUIC draft, that you may need codec-specific knowledge to packetize the payload of incoming RTP packets into smaller RTP packets. Next slide. But when you're using S-frame, only the endpoints have the key, so any middle box can only know about S-frame, not the clear text payload. So when it says may need codec-specific knowledge, maybe that really means it may need S-frame specific knowledge. Next slide. Now, someone might say, well, what if we just use S-packet instead of S-frame over RTP over QUIC? But that has the same problem because you can have a really large RTP packet using S-packet as well, because when you have really large RTP packets, like with QUIC streams, there isn't much difference between S-frame and S-packet because you basically have one frame per big RTP packet. Next slide. Similar, but somewhat different. You still have the problem if you do RTP over QUIC streams. So this isn't unique to QUIC, or sorry, over QUIC datagrams. This isn't unique to QUIC streams because if you have QUIC datagrams, you can have slightly larger overhead. So when you translate in the other direction from RTP over UDP to RTP over QUIC, you can end up needing to repacketize to make it the payload slightly smaller so it fits with the slightly larger overhead. Next slide. So a summary of the problem is that with RTP over quick, you can have big RTP packets. You can have MTU differences also, and these require repacketizing. But repacketizing, as mentioned in the RTP over quick draft, is may be codec specific, which might mean S-frame specific. And this can't be solved purely by the endpoints. This is something the middle box needs to be able to do, but it has to work within the bounds of what it has with S-frame, which is encrypted. Next frame, or next slide. So here's a potential solution. It's pretty simple. Next slide. This is the RTP packet format. Everyone knows what it is, but look at the payload part below. Next slide. And the proposed solution is to basically add a payload that has an S-frame sequence number, an S-frame chunk index, and then an S-frame chunk. I'll give an example in the next slide, but you might think this looks a little bit like RTX, where there's another sequence number. In RTX's case, it's the original sequence number, which is reused. And in this case, we're reusing the S-frames sequence number, but we'll do it multiple times, one for each chunk. So next slide, I'll give an example. So if we have two large RTP packets being sent over, say, quick streams that have payloads of A, B, C, D, E, F for the first one, and G, H, I, J, K, L for the second one, imagine it being much larger, obviously, then that can be broken up into small chunks of, say, A, B, C, D, or sorry, A, B, C, D, and E, F, and then G, H, I, J, and K, L. And the original sequence numbers that were in the large RTP S-frame payloads, well, the sequence number tied to the payload, would be maintained in the payload of the smaller RTP packets. You can see there 101 3 times, 102 3 times. And then the smaller RTP packets have normal sequence numbers, 1, 2, 3, 4, 5, 6. And to keep track of how to put the chunks back together, when you receive them all, the chunk indexes let you know what order they go in. So it's a pretty simple chopping up of large RTP packets into small ones in a way that you can put the large one back together when you get all the small ones.
Magnus, you have a comment?
Yeah, Magnus Westlund. I think you might be missing one important functionality, because these fragments can be lost under certain conditions. I think you need the indications of saying this is the last fragment.
Yeah, that's a draft. But there are two different ways we can do that, and the way I have it written down at the moment, we use the marker bit, but there's a slide later where there's some technical discussion we can have over different options. But before we get there, I want to make sure we decide whether this whole idea is worth going down as a solution for SU 29.
I mean, from my perspective, I think considering what S-frame is, etc., you're not going to be able to do anything better than just take the whole S-frame, chop it up in the suitable way for the underlying transport, and doing that in the RTP payload format seems to be the reasonable way forward here. You might also have to consider if you need, if the chunk index, if it always starts at 0, you always know where the start is, so I guess it's fine,
Yeah, another one of the issues that trade-offs we can discuss, which is on a future slide, involve whether to use a chunk index or kind of derive that from the sequence number with the first bit. So there are different options we can have. But like I said, first I want to open the question. If we go to the next slide, perhaps.
Yeah, we do have one more person in the queue. Jörg, did you want to speak to this slide?
Yeah, quickly, Jörg Ott. Thanks, Peter. So fundamentally, I kind of think this should be workable. How does this thing work with cascaded translators? After all, you are creating a consecutive index sequence. And I suspect if you had a requirement to do the whole thing at a second stage where you still get even smaller packets. Had you thought about that?
No, I had not thought about that, but I suppose that you could have 2 layers of it where this smaller one gets broke up into even smaller ones, and then you have
maybe
payload and a
one
payload.
just needs to think about this. I also had a general question to the group, maybe also to Magnus as the living AVT directory, dictionary, whatever. I try to find, translators have existed for a long time. So in that regard, MTU size considerations would have needed to be addressed for a long time. But looking at the topologies draft, I couldn't find anything. That I don't think the term MTU even appeared in that document. I'm not sure, going back to the original RTP specification, whether translator definitions actually talked about MTU sizes. So did we have a solution to this problem in the past that all of us have forgotten, or did we simply ignore it back then? I'm just seeking insights here.
S-frame's a fairly recent thing, so.
No, but even if you had regular RTP packets that go into a translator, they might be ended up being sent on a network segment that has a smaller MTU size. Then you would have the same problem irrespective of S-frame.
Right. So the RTP over quick draft right now already says basically you can do repacketization in a codec specific way. So I assume that's always been the answer.
I know what our draft says. I'm just curious what people did in the past, if they did anything.
Well, in conferencing, it was there. We have seen repacketization, and it is as was described in the RTP over quick draft, which is it's codec specific. So the conference server can repacketize, say, for a participant with a lower MTU in a codec specific way.
And you can do this,
yeah. I mean, the translators always repacketize. I think, there wasn't not typically for MTU issues because people were mostly thinking about audio, but certainly like changing the P times, which is essentially basically the same thing. So.
Okay. Thanks.
Peter, just quickly, do you have more for your slides, or
should
we general discussion?
Yeah, there are a few more. Can you go to the next one?
Okay, sure.
Yeah, so as I mentioned, the slide after this has some, technical discussion we could do, but I first wanted to ask whether this is a direction worth pursuing for issue 29, and if not, what's another solution for this problem?
All right, so I guess Mo, you're next in the queue, or?
Mo Zanetti, the mechanics of the chunking seem like it would work okay. One small nit would be, I think, should look into having chunk offsets instead of indexes. I think, a lot of different fragmentation and reassembly techniques go back and forth between indexing and byte indexing. You should look at that to see what use cases work best for you there. But at the highest level, I'm scratching my head a little bit about the purpose of this, because I thought one of the main goals of S-frame was to have single auth tag for some media, for some large media, and now you dice it up however you want, deliver it however you want, and then when it gets there, you still have this one big large auth tag. But that means that everything delivering that in the middle can't authenticate that thing, and so you have this object that's maintaining state across all of your network that's delivering these things. And so it seems like the benefit of S-frame of being able to just have this single auth tag over a large media frame, and now you're going to chunk it back down into smaller objects. Are you going to authenticate those smaller objects as well? And if so, wouldn't that defeat the whole purpose of where you started from in the first place of consolidating that auth tag? And if you're not going to do that, then don't you run the risk of providing AMP vectors for attackers that can flood, a lot of unauthenticated packets to a lot of different parts of your delivery network?
I've always viewed the purpose of S-frame to be the end-to-end encryption, but if you want to do hop by hop authentication of the whole frame using S-frame, a middle box still could, because it can reassemble the frame from the chunks if it wants. It would add some latency to authenticate that before forwarding the first piece, but that happens the same if you're going to read the entire quick stream and authenticate it before you start forwarding the quick stream. So it's kind of the same thing. You can still do that.
So you expect the chunking to be purely hop by hop context with no end-to-end guarantees, right?
Yes, but any place in the middle could reconstruct the entire frame if it wanted to before forwarding the pieces. So it could apply the end-to-end guarantees if it wants, just like it could by reading in an entire quick stream and then sending it out. But if it doesn't want to do that, it can just forward it immediately. So it's kind of up to the middle box to decide.
I really don't know.
Sergio?
Hello, hope my audio is okay now.
Yes.
Yeah, well, my first question is, it seems that you are only trying to solve how to interoperate between quick over datagrams versus with quick over, well, better said, quick over streams to quick over datagrams when using S-frame to encrypt a whole and an RTP packet with an infinite MTU. Is that correct?
I think so. I think if I understood you correctly. But more generally, anytime you have to take a larger RTP packet and break it up into smaller RTP packets, then there are various reasons you might have to do that. And you can't do it in the classic codec specific way because you're also using S-frame.
Okay, but this is first, just to try to narrow the scope. This is something very specific to RTP over quick because how the way that they are doing quick over RTP over quick over streams, because it will require packetization. But first, I think that we are trying to solve a problem without even specified how packet over packet is going to be done in RTP or in SDP. So I think that it is a bit of trying to solve one problem that it is not even on the table, because first we don't know how to packetize or signal S-frame over even in the version that does the packetization of the whole media frame, or even if it is in just in the RTP packet. So I think that is a bit premature, and that's. I mean, as I was trying to make this work with in a generic way and has hit some walls to get it done. I like to see the discussion going, but I'm not sure if just narrowing it down to how we are going to or just to specifically to the quick over datagrams versus quick over stream is a good way to solve the issue.
Sorry, can you repeat that last part?
Yeah, that I'm not sure if you are trying to just solve a very narrow part of the S-frame as packet without even have the without being I mean without even have specified how S packet works with a normal RTP. So I'm not sure if we are starting to look at the problem in the from the brown edge.
So are you suggesting that this problem would be solved somewhere else? Is that what you're suggesting?
No, my question is that we don't even know how S packet is meant to work with RTP. So we are trying to make to solve the interoperability between S packet with Overquick when we don't even have specified how S packet works in normal RTP.
But it kind of doesn't matter. Anytime someone would have an encrypted payload, regardless of the mechanism for that encrypted payload. Like, for example, right now, with the WebRTC APIs, an application can do its own end-to-end encryption mechanism, right? And anytime you do that, and you try and do it, and now you try and apply that with RTP over QUIC, you're going to run into this problem where one side is large and the other side is small.
Yeah,
So,
but you can do it in a way that it is not specified by any RTP specification. So try to put an specification to solve something that it is unspecified. I'm not sure if it is the best way, because first we will have to specify how to handle or to transport normal this media encryption, media encrypted format over RTP without being something that it is completely ad hoc or just depending on what whatever format the people are using to encrypt the content.
okay, well, then it sounds like basically you're saying is we don't need to solve issue 29 because S-frame and S-packet aren't mature enough in their standardization. And so we should wait until they are. And perhaps that's what the working group decides, but that's kind of my question. So I think we should work on it before that, but sure, I can understand that position.
David?
Thanks. Sorry, I was in the queue, but then my laptop went to sleep, and Miteko thought, he's probably not in the room anymore. Anyway, David Skenazy, quick datagram enthusiast. Good to see you again, Peter. It's been a while.
Yeah, you too.
So this, I mean, like the problem you describe is a fundamental problem in packet switch networks. Like when you go from circuits to packets, then you have MTU issues. And this was, one of the early things of the internet. And in IPv4, they were like, oh yeah, we have this problem. All right, let's allow routers to fragment packets. And what you're describing is just a clone of IPv4 fragmentation, if I am understanding it correctly. That doesn't work. That works horribly poorly because, once you fragment something, a single loss ruins the whole thing, especially in a context where you have like security with a tag, like you can't decrypt anymore. And in IPv6, we, banned that because it didn't work. So I don't think this is the right solution. If quick datagram frames are what's shooting you in the foot here, one option is to switch to quick streams.
This is quick streams, David. Yeah, I think you're.
Okay, so then maybe I'm misunderstanding. Then why are you fragmenting it? Where's the MTU coming from if you're going over a stream?
You have a conference server, and you have participants with different MTUs, and some are RTP over UDP, some are RTP over QUIC. Yeah, this isn't a routing scenario. It's a conference server. It's an application layer thing. That's how RTP kind of works.
So like you have a frame that you want to send to a bunch of people over mixed media, and then some of them it's going to fit and some of them it's not going to fit. Is that the idea?
Yeah, some of them are RTP over QUIC, some are RTP over UDP. That's kind of what a translator does or a conferencing server.
Yeah. I see. Yeah, these like intuitively doesn't feel right to me, because like I can see how like the previous model made sense where you would re-encode and like do codec specific things at the splitting point, which made sense. But it sounds like here what you want is what we ended up doing in IP, which is path MTU discovery. So you kind of realize this is happening, tell the sender not to do that. But maybe I'm misunderstanding the problem. So
conference servers aren't routers. Yeah, conference servers aren't routers. So MTU discovery doesn't work through a conferencing server, like end to end. Yeah.
All right, it's just possible that I'm misunderstanding. I'll do more reading.
If it helps.
So when you say that, then people are, maybe I'm not completely off. When you say it's not a router, it takes things coming in on one side as packets and it sends it on the other side as packets. And you're proposing a fragment. That sounds like the same thing as a router, doesn't it?
Oh, no, an RTP translator is not a router.
No, I'm not saying it's a router. You're redoing the same thing that the router does at a different layer.
That's not true either. That's not how conference servers work or translators. No, it's not similar to a router.
I think you're looking at different layers of abstraction.
Yeah. I'm not saying they're a router. I'm saying it's fragmenting, and this is fragmentation, is it not? Maybe I'm confused.
It's not fragmentation. It's not fragmentation. No. It's repacketization. There's a difference.
I don't think you're actually disagreeing. You're just talking about. I think David's just at a higher level of abstraction than you are, Bernard.
Mm-hmm.
All right, I'll go sit down. Sorry.
All right, I think I'm next to you. I think. All right. So as an individual, Jonathan Lennox, I was going to say I feel like, regardless of how we solve this, I feel like this is a problem for the S-frame over RTP draft to solve, not the RTP over quick draft to solve. I think that, mostly having to do with, A, this is an S-frame specific issue, and B, RTP over quick is significantly further along the process. So I feel like, maybe the RTP over quick draft should say, rather than just say codec specific, say codec or, other, a meta codec container or whatever, and, have some informative reference. But I think the actual issue to solve should be solved in the S-frame document, rather than trying to solve it in the RTP over quick, because A, it's applicable to anything that needs to do MTU, have MTU problems, not just for quick streams, and B, I don't want to have a normative dependency of RTP over quick on S-frame when S-frame is significantly less far along the process.
Well, on the second issue, that we don't have to have a normative dependency in S-frame if we don't want to, because there's nothing in the solution that needs to reference S-frame. It's just that S-frame provides a motivation for having a mechanism like this. If there was some other mechanism for encrypting end-to-end that disallowed RTP over quick being able to be translated to RTP over UDP, you would have the same issue. So in a sense, it's not S-frame specific. It's just end-to-end encrypted.
Yeah, I agreed. But my point is that I think S-frame has this problem regardless of whether you have RTP over quick or not. So I feel like S-frame is the appropriate, and I feel like in some sense, this kind of fragmentation is what you're doing with S-frame to begin with, which is that you're taking a frame, encrypting and authenticating it, and then chopping it up. And so I feel like if we design the chop it up process such that you can re-chop it up without messing with those tags, I feel like that solves the problem. Yes, the translator still has to have an S-frame aware knowledge if it's going to do that re-chopping, but that's sort of what this draft means by codec aware. This meta codec, not the codec proper, but it's still, I think it doesn't change anything about how RTP over quick works, and making sure that the process is possible is S-frame's responsibility. And I saw some thumbs up in the room when I said that, so.
So then for your suggestion is for issue 29 to say, not my problem. If you want to use S-frame with RTP over quick.
Move issue 29 to an issue on the S-frame document to make sure that it can be, chunked and re-chunked properly.
There's no S-frame over RTP, is there?
Yeah, I think this is an appropriate time for me to leap in here as someone who's been working on S-frame. So the direction that the S-frame working group is going in right now is to make the S-frame document specify only the encryption framing, because there has been so much ambiguity around frame level versus packet level versus other ways you might choose the units that you encrypt with S-frame. And so I sort of agree with Sergio, like how you carry an S-frame thing in a chunk of data that is encrypted with the S-frame encryption framing in an RTP packet, in one or more RTP packets, right? Because you can envision in the full frame version, we have multi-packet frames, like you might have multiple RTP frames carrying a single S frame unit. So all of that is super ill-defined right now, and there's not really a path to getting it defined. As far as I know, the S-frame working group is focused on getting the encryption bits done. So yeah, there may be some intermediate work here to be done in any case with regard to S-frame, which is probably not the job of RTP over QUIC. I was sort of going to plus one David here, and that this seems like a generic issue, not an S-frame issue at all. This is a generic issue for, actually, as Peter said at the very top of this presentation, like the underlying issue here is doing this repacketization when you don't know anything about the underlying codec. And that could be because the underlying codec is encrypted, because of S-frame, could just be because you as the repacketizer don't know anything about it, and so you can't make any intelligent decisions about the data you're looking at. So it seems to the degree that there's a solution necessary here, you know, it's to that problem, not anything to do with S-frame in particular. It's the how do I repacketize this without knowing anything about the codec. One final note to the Bernard and David discussion that was just going on about, you know, whether this is a router or not. It does seem like you could have something PMTUD like here, or path MTU discovery like here, in the sense that, you know, if you have an SFU that is sitting in or a conferencing server that's sitting in the middle of a bunch of connections, it knows, and it's doing repacketization, and it has some idea of what the MTUs are out to the endpoints it's serving. And so, you know, in principle, if you had the right control plane, you could distribute that information, have people send those MTUs, and do, you know, bunching and not not fragmentation. So it seems like there's some similar solution space there to the general routing case.
So I just want to make sure I heard correctly just now. The people in AVTCORE said this should happen in S-frame, and the people from S-frame said this should not happen in S-frame. Did I understand that right?
I didn't. I said no. I think we had an S-frame over RTP document, didn't we?
No.
Maybe, I think we need one. If we want to send S-frame over RTP, and that's not being defined in the S-frame work, it should be defined here. So it should be defined here, and that's where that work should be done, I would say. I don't care if that document is in S-frame or AVTCORE, but there needs, if we're going to send S-frame over RTP, we need a document defining how to send S-frame over RTP written somewhere. And that document should define how this repacketization is done.
Okay, so do you just want me to rename my...
But this is, I actually disagree with the very end of that sentence. I think we probably do need a document. I think AVTCORE is probably the right spot for it. But I don't think that this issue actually touches that, because, well, I mean, maybe as an S-frame over RTP doc would need to deal with repacketization, but like it seems like QUIC over RTP is the one that has a generic, you know, I don't know the codec repacketization issue. So
yeah, I think
unless you require every
RTP
thing to have
you can't do that. Basically, RTP doesn't work that way. You can't do generic repacketization.
Okay.
Bernard, I guess you're up next.
Yeah, I mean, I think you bring up a good question, Jonathan. We've been waiting for almost 2 years for an S-frame over RTP proposal. And, you know, since S-frame is only transported over RTP, not having a proposal for the only way it can be transported is kind of awkward. Something I know there's been discussion among the ADs of closing the S-frame working group and just giving, moving it somewhere else, but it seems like there has to be a document here somewhere.
Just to give a brief update on that front, I believe the current state of that discussion is that the S-frame working group folks are refocused now on getting the encryption framing done, and there's not really a horizon beyond that.
Bernard, are you speaking? Are you still in queue, or is that your comment? Okay, Harold, I guess you're next.
I was just wanting to make two comments. Harald Weststrand. One is to the S-frame over RTP thing. That was the proposal that was put forward a couple of years ago was the so-called generic RTP encapsulation, which flew like a lead balloon. So it's not that it's not been proposed, it's that the proposal was rejected. And the other point was the move, which is that if your S-frame is intended for end-to-end encryption protection and so on, if you try to over-constrain the problem by insisting that it should support verification in the middle, I think you'll quickly end up with a null set of solutions. So please, if you want hop by hop, use SRTP. If you want end-to-end, use S-frame, but don't ask S-frame to do hop by hop.
Yeah, just to briefly respond to that, I don't think I was saying we'd want re-verification in the middle. I'd say the middle can opaquely rechunk the authenticated thing, and then it's the end's job to undo that chunking and verify the authentication.
Yes, I'm just saying, I mean, middle can do anything it wants as long as it can do it. I'm saying that if we try to write the specs so that we require that it should be able to do it, we lose.
Magnus, you're up next.
Yeah, Magnus Westland. Yes, fully agree with Harald's second part here about, yes, use hop by hop for hop by hop protection and end-to-end. And on the general issue of RTP fragmentation or MTU issues dealing, I mean, for any RTP payload format that sends any significant size payload that can be larger than expected IP MTU, basically need to have some type of fragmentations to deal with this datagram. And the model, to my understanding, has all along been that, yes, if you're going to have, either you send small enough packet that they fit in all the links, or you need to have an RTP middle box that can actually re-fragment the packet into something that, the payload into something that fits the RTP packets. That is kind of have been the model. I think we have some discussions around things like, oh, how do you actually detect what's MTU that works within this, especially in the context of SFA. But yeah, it isn't great, this model, but it is what we have, etc. And I think in the context of S-frame, yeah, you're going to have to write that RTP payload format, and I don't see a way around defining a generic S-frame payload format which can fragment. You're going to need something again, and it's just how smart can you do it. And yes, it's not going to have ideal transport properties. You lose a fragment, you lose the whole frame. It's going to be that bad, but yeah, I don't see an easy way around that. And when you start to talk about like RTP and quick, etc., you have choices where it makes this better by relying, for example, on individual streams per frame and things like that. If you can do it, if you have other message-based transmission capabilities that's focused on just transmitting one data object, so you don't have to care about that. So.
Well, Harold, should I remove you from the queue?
Mosinati, so just to clarify what Harold said earlier about what got rejected, there's some nuance here that maybe people are missing. What was rejected earlier was S-frame was first attempting to have a generic packetizer over the RTP elementary stream itself, not saying this is one giant frame, pretending to the media encoder that this is one giant frame of limitless MTU. The media encoder generates an RTP frame, an RTP packet that big, and then S-frame can wrap that. We're originally talking about dicing, having a generic packetizer over the elementary streams of the RTP packets, of the RTP payload formats. And that was rejected because there's a lot of nuance in how to do that. And you know, different payload formats do it in different ways. And it's difficult to harmonize all those together. So I think it was wise for the S-frame decision to say, no, we're not going to do that. We're just going to say, give me one big RTP payload, and we'll take that as, and wrap that with double encryption. So that part, I don't think we should go back and revisit. But now this large object that now needs to go over some transport that likely can't carry that large object is the next problem. And is that S-frame's problem, that it needs to have a packetization format that is natively chunked? Or is it the transport that's carrying S-frame's problem, that it needs to chunk something big and have its own headers for managing that chunking? I think that's really the fundamental question. And I would argue that S-frame knows it's going to go over some transports, and it knows it's going to get chunked. So why would it not have a native chunking inside of it? So I kind of agree with Peter's direction that it needs to, whether it goes over RTP or over anything else, it's going to go over packets, and it probably cares about how it gets chunked into packets. So I think it does make sense to define something like this. I'm a little bit concerned of how naive, you know, the simple approach is, because it seems like it's automatically going to double your packet rate if there's ever an MT mismatch, and that can totally destroy a lot of networks that are packet rate sensitive. Your media delivery may end up being, you know, twice as bad as you expected because you have a 2 or 4 byte MTU mismatch. So that would be a bad outcome for a naive encoding like this. But I think it is fundamental to S-frame to know that it's going to go over smaller object transports and define its own chunk layer inside of it so that the higher level transport doesn't have to do something special for it.
I think we're probably going to have to cut the queue.
Yeah, I
cut the
agree.
queue.
I'll cut the queue and I'll.
So I'm Spencer Dawkins. I got up to say something a long time ago, but I actually do think I remember what it was. The introduction of the abstract of the RTP over quick specification talks about it doing a minimal specification. And that was kind of where I thought we were going at the last meeting or two. And I'm not reporting a problem. I'm making a suggestion that we may want to decide what problems really need to be solved in that specification, and what problems need to be solved in other specifications more broadly than just MTU mismatch. We've mentioned conference bridges and things like that may be translating from RTP over quick to RTP over something else. And you know, the topology draft, the topology RFC is a pretty good sized chunk of writing. I think it would be good for us to be looking at that specifically, you know, like what topologies, rather than expecting the minimal specification draft authors to solve that problem on their own. But I know you all will do the right thing, and I don't actually know what the right thing is. But like I said, I would suggest that we think for a little bit about feature creep. And I am fine with the answer changing because, I mean, time has passed and we're now talking about a working group adopted specification and not just a couple of really smart guys writing a draft. So it's fine for the answers to change, but for us to just be real explicit about what target we're shooting at. And I think that may make some other things easier to solve too. Thank you.
So, Cullen Jennings here. I think going way back to David's comments, I mean, we do have a complex, router, not a router in the RTP terminology sense of it. But we have a device in the middle that needs to occasionally send things out over things that are not quick streams or not a TCP stream that this chunk or that this thing data arrived in. They need to be able to rechunk it or make sure it's small enough to get down to those smaller connections, right? And Jonathan, you said like we've got to have that. It doesn't work over RTP if it can't have that property, which seems true. And we've got another group that's Richard's trying to make it not be S-Frame's problem, the S-Frame working group's problem to figure out how to solve this. Which I mean I understand that too, but we're just creating an impossible set of scenarios here. So I think that the way that makes sense is a way out of this to me. Is right that this fragmentation inside the network, which is what this is always problematic, and it's a very hard problem to solve, and that's what we're running into. This was mentioned when we chartered all of this work in the first place, by the way. So I don't think we can do path MTU discovery. I think it's too hard to do any form of that across a conference because people come and leave too quickly, and we've never got it to work. So I think that's fantasy, and I think that really only leaves us one real option, which is we pick an MTU of 1200 in S-Frame, and the S-Frame documents are defined such that the S-Frame working group and what comes out of that is never passing into the RTP layer, something that's chunks bigger than that. And yes, I understand there's networks with MTUs smaller than that and everything else, but like we're going to have to accept some limitations here. We've set up an impossible set of constraints, and that's the thing. I feel Peter's pain on. He's like, you guys are telling me to do this here and that there, and you're like, I can't figure out how to just finish this work. So I think that we need to think about what our constraints are and which ones we're willing to violate, which ones we're not.
Can you go to one more slide? Right, so we're basically deciding how to proceed. and it sounds like maybe a separate draft with a different name, but here in this working group?
No, I think that's complete garbage. Okay, that doesn't help. The splitting, the number of drafts or the number of working groups is not the problem here. It has nothing to do with the problem. So that will not fix it, and it won't help, and we shouldn't even discuss it until we figure out how we're going to solve the problem.
So we have to solve the problem before we can decide where we're going to solve the problem?
We have decided where we're going to solve the problem, and it's the S-Frame working group, right? Like that's if you read the charter or whatever, I don't even care. It doesn't matter. It's the same people that have to solve this problem, right?
The S-Frame working group just said they're not going to solve this problem.
Well, one member of.
I think a member who happened to be the chair, perhaps, but I mean, I don't know. Like, I guess the thing is that I don't. Here's what's going to happen to you, Peter, on this, is you're going to go solve it in that working group and everyone's going to agree. Then you're going to bring it over here and a bunch of people are going to tell you that what you've done violates the tenets of RTP and that you must go away and bring them a different stone. Like, it's not going to end well.
I mean, is this the same thing as what you got up a little while ago and they all said, go do the independent track?
No. I mean, no. This one, they're going to not tell you to do the independent strat. They're going to tell you you're not allowed to publish your document until it fixes a problem that's impossible for you to fix. Okay, Magnus, come give us the answer. Like, somebody just needs to suggest a good solution to this problem, and then we can figure out what documents. So,
I mean, the S-frame fragmentation is not RTP over Quick's problem. It's S-frame's problem, and it's from my perspective. Either you do it as general as most suggesting in S-frame to fragment. However, I think is there any other cases where S-frames gets fragmented? If not, do it in the bloody RTP payload for S-frame. You're gonna need one. The right home for that document, I still think is here in AVT core, because it's gonna be RTP problems more than S-frames problems. If we just treat this as a blob, there's some signal issues around this, which is I still don't know if anyone's figured out. But yeah, so that's, yeah.
I'm happy to rename my thing S-frame packetization for RTP or whatever and do it here.
That would be a
I don't
wonderful
care.
document.
I don't really.
Repeated in 2 years.
Sorry, what?
That'd be a wonderful document, but it's not the document you set out to propose here. I think it's a different topic. But I think, yeah, the short problem here is like whether RTP is okay with repacketization that doesn't pay attention to codecs, because that's the underlying problem here. The only thing S-frame is doing here is making it so you can't see the actual codec. If that's a solvable problem, we should solve it at the RTP layer so that we don't have to redo this for every so we get the generic decoupling. We don't have to do it for every case where you can't or don't want to look at the internals of the codec. If it's not a problem, then we can't do S-frame over RTP without PMTUD.
So as an individual, and I've cleverly arranged so I get the last word here, I mean, RTP was designed to have tight couplings to the codecs because there's a lot of benefits to that. And one of the consequences of that is, no, you have to know about the codec if you're going to do things with the RTP payload. And yeah, that's a trade-off. And if you want to just, I mean, that's why we use RTP and not just send these things over TCP. So so for S-frame is potentially a meta payload. So something we'll have to know about S-frame to do this work, but that's fine. It won't have to know about the contents because, as you say, it can't any more than it doesn't know about the, it might be able to repacketize H.264 with fragmentation units, but it doesn't have to know about how, inverse cosine transforms work or anything like that. And so I mean, I think, and as I said, I think what Peter said is writing an S-frame payload for RTP would be an excellent document, entirely in scope of this work group, and something we've needed for a while to get S-frame working, to actually have S-frame defined. I mean, I would have thought that it would be in scope for the S-frame working group too, but if you want to do it here, I mean, I think the argument that it needs the RTP knowledge is fine. I'd be happy to say it's in scope.
But Jonathan, when Colin presented the game state data, it was kind of the response of the group that the media should be done outside of the AVT core, and then the packetization should be done in AVT core. So it is kind of, I mean, depending on the codec, we choose to do the packetization outside of the AVT core or not, or how does it go?
Yeah,
because
I mean, I think it's the same thing applies. That's you do the crypto transforms outside, and then the
so S-frame has to make sure that it is that it works in RTP, but I think that the RTP packetization for S-frame or S-packet must be done in AVT core. I have presented several times the generic packetizer, try to overcome the issues raised by the AVT core group, and I failed. So that's why it has not been further progressed. It is not that we have not made extensive efforts to make it work in here, but it is not possible under.
Well, I mean, I think it's not that the concept is bad. It's that you need to have codec specific. You need to expose enough codec knowledge such that things can make intelligent decisions. And honestly, I feel like this is one of the problems that S-frame has had is that because of the pandemic, we haven't been able to have side meetings in this. I think if we had a 2-hour side meeting with the right people, we'd have all this cleared up and we'd have figured it out 2 years ago. So I think
but anyway, I mean, just try to move forward. I think that this
the problem is we need the people who aren't here.
This is coming from the fact that the RTP Overquick has decided to make something that it is not playing well with the rest of the RTP implementation out there. I mean, we have never have a problem in real life about MTUs. I mean, we have SPUs that forward packets from one network to another. Even if the MTUs could be different, I mean, which in reality I don't know if it is the case. There has been no issue in transferring packet without having to repacketize. I don't think that.
Sorry, I mean, I think it's absolutely true that until now, I think Colin's thing of just assume the payload MTU is 1200 and work with that is what everybody has done, and that's been fine. One of the ideas of RTP Overquick is because you have streams, no, you can treat it as though you have unlimited MTUs, and that works. But that means that yes, if you're gatewaying to something that still has that limit, yeah, David puts.
Yes, but that's a problem that RTP over
Then you
QUIC
have that
has
problem.
introduced
So,
it, because they are, if they use, instead of transmitting the frame as a single RTP packet with infinite MTU, they would split it into smaller MTUs with RFC 45771. The problem will go away. So it is a decision that has been made by the RTP over QUIC to send the RTP packets with an infinite NTU that in fact does not play well with any other RTP over any other thing. So instead of pushing this problem with to S-frame or to other media formats, I agree with what Richard said, that it is not only a problem with S-frame, it's a problem if we want to do an SVU or a media element that does not really need to have knowledge of the packetization and the packetization of the codex itself, because it is not what typical SVU does. So we are adding an extra requirement to these network elements, and just because of what RTP over QUIC has decided to do with the QUIC streams. And it has just left as it is an architectural choice, and it has just left to the topology. But I don't think that it is, or the problem now has to be spread to other media formats, just to how to do the repacketization when, for example, this frame is meant to be encrypted and not possible to do the repacketization.
So I guess your point is that issue 29 is a special case of the idea that because the infinite MTU abstraction is causing problems for anything where you need to gateway to traditional RTP over UDP, and yeah, that's true. And so maybe that's something that the RTP over quick draft could talk about, not specifically to S-frame, but in general, the infinite MTU causes problems. So maybe that's something that the RTP over quick document should talk about.
To move to the next item now.
Yeah, I think so. We're like way over time.
Oh, but I never got an answer about where I'm supposed to go.
Well, we're talking about RTP over quick now. So.
Kind of continued fun.
Could I just suggest that scheduling an intern meeting or something, like scheduling a meeting with the right people for a couple hours seems like your only hope of solving that problem.
I would tend to agree, yes.
Okay, for the notes, indicate we'll do an interim. Thanks.
I mean, or possibly a side meeting, not a formal interim. I think this is something that needs more informal discussion rather than a formal working group meeting.
Okay, now that we have been alluding to RTP over QUIC all the time, we can actually get to it. Yeah. Next slide. Hooray. So we have done a bunch of updates, one that actually pertained to this entire S-frame discussion we had for the last 10 minutes. So some of the stuff that you were asking for is already in the document. I'll talk about that in a second. So we had a bunch of different updates, allow for mixing streams and datagrams now. But I want to first talk about the length field in quick streams. In order to support translators or things like that would actually need to chop big things up into smaller things. Next slide. We have included an explicit length field here so that a sender could actually do sender-side segmentation into meaningfully sized chunks while still transmitting the whole thing over a quick stream, and you would find the identifiable borders like you do when you try to send something over TCP, over SCTP, or something else. So that would allow, if there existed an S-frame fragmentation, to come back to our previous discussion, at the sender, to preserve these boundaries that you insert, even though you are using a quick stream for transmission. And then a translator would have the natural packet boundaries to send that forward. The choice of the size of these frames would ultimately be up to the sender. And if you have negotiated that you're talking straight over streams to directly to a peer without any translator, then maybe you don't need those. If you have negotiated something different, then you can choose smaller units. And this may be one ADU, one frame per stream, or it might even be multiple ADUs, multiple frames per stream. There is one subtle problem with the letter part that I want to talk about on the next slide. So if we can send one or more packets over the stream, we had mechanisms, or we do have mechanisms in the RTP over quick draft when using streams to cancel outstanding transmissions. So a sender who is figuring out that maybe my queue is too long, this is never going to make it up to the receiver in time, I can send a reset stream to terminate this transmission. At the same time, a receiver could possibly find out that, oh, stuff is coming in too late, I'm not going to use this packet anymore, or this ADU anymore. So maybe I should tell the sender to stop retransmitting, and so I could send I could cancel a stream using stop sending. The interesting question is, the moment we may have multiple packets on that stream, the sender doesn't exactly know whether the receiver doesn't exactly know whether the sender has put one ADU on the stream or multiple. So if I would say stop sending and cancel an incoming stream, I have no idea how many bits I'm going to rip off of that stream. So what I'm going to lose. Next slide. So first option is
we do have some people in the queue. So
it's actually correct. Right side.
Okay. No, just Sergio, do you have something you want to say? Or are you just in the queue from before?
Okay, so first option is we just accept that you can't safely cancel streams because you don't know what might be coming up. That is related to option number D. It may be implicit from the application context. So maybe you have an agreement that you're always going to just use one ADU, and maybe this isn't the problem that we need to solve at the transport layer, and so we are just done. We could also require just a single ADU per stream, would be an option, but we might also have a single group of pictures or something on the per stream, because they are dependent, they exhibit dependencies anyway. So maybe that B might be too harsh an option. Or we might invent some signaling, but that appears to be arbitrarily complex to have semantically rich enough expressiveness. So we probably have a kind of a tendency to go for solution number A. Just curious about comments from people. Does anybody care?
Bernard, you're first in the queue.
Yeah, I mean, I think there's an inherent advantage for the sender to cancel a stream because it knows what came out of the encoder. So for example, it knows it's a keyframe, I can't really cancel it, I need to get it through, or maybe it's an enhancement layer. So when I was implementing this, it made the most sense to do the cancellation on the sender anyway. So I think you've stated the issue, and I don't see why the receiver would have to do the cancellation, and maybe you just say, hey, only the sender can do it in this case.
That might be option number E. Okay, we don't have that on the list. More comments.
David?
David Skenazy, Quick enthusiast. There is no such thing in Quick as a receiver canceling a stream. Like we're talking about unidirectional streams. A receiver can send a stop sending frame.
That's what I meant, yeah.
Yeah. But the important distinction there is the stop sending frame does not cancel the stream. The stop sending frame tells the sender, please cancel the stream. Okay. And so the sender has to, just in Quick, decide whether to cancel the stream and to send a reset stream, and when it will. So
okay, so it could ensure the
exactly.
integrity, and we are done.
Yeah, so that's
Right.
your easy solution there is you should add some text to say that, like, if you receive what to do if you receive a stop sending, like, don't do the dumb thing, be smart about it.
Yep.
And that might, your life might be a bit harder because some quick implementations might just say, okay, they said stop sending, I'm going to reset the stream right away without sending it to the application. So that might be an implementation issue, but from a standards perspective, there's no problem here.
Awesome. I missed that subtlety. Thank you.
Lucas?
Hey, Lucas Pardew. I love streams. Like, this stuff causes so many bugs. As David said, yeah, I'm aware of bugs where people have received stop sending and not actioned it, and all sorts of fun and games. But for me, I don't understand RTP that well to know what's safe versus unsafe. Is this like safe in the security sense, or is it just non-optimal that some things get dropped on the floor? That might help to understand the problem, like the impact of the problem we're talking about here.
Basically, it would be as though you had lost the packets in a traditional RTP or UDP. So you'd have to do whatever recovery, either NAC
Right.
or.
Okay, so it's not.
It won't get worse than sending datagrams and those being dropped from a queue.
So that doesn't seem too bad, and like HB3 has this problem, right? We send frames on streams, and if you get reset at any point on that stream, you don't know what frames are going to come after it, and we kind of live with that. Yeah, just accept that this could happen, I think is what we're saying. And maybe you could say, well, like David just alluded to, implementations could do something smarter and try and send the reset at the right, the offset that makes sense from the packet. The problem I think you might hit, though, is that if there's any, if you're expecting that all of the data before that reset was received on the other end, it might not have been before the other end sees the reset stream and it discards all the state that you were hoping that it would have read beforehand. Like, there's not going to be any retransmissions at that point. So you're probably still in the situation of A anyway. It could happen, but it's possible it wouldn't as well. So that's something that people would probably have to accommodate.
I suspect with David's comments, we'll need to bang our head a bit, get our head around that in order to see what kind of interaction that actually leads to, and given that also every interaction causes an extra RTT, what that then in the end means for a sensible choice of action. Colin.
So I think, notwithstanding David's comment, which is great, I do come sort of towards back to A, because I'm thinking about the use cases where we use this, and usually what you want to do when you're doing this is you really decide you're abandoning the whole thing, everything you previously sent, and you're trying to get the bandwidth to stop as quickly as possible. So I think leaving, and stuff that's already been sent, you can't cancel, it's already in flight.
Right.
And the basic model of RTP is you're never guaranteed anything was going to happen to get delivered anyway. So some packets didn't arrive. It's just within the RTP model. I think what at the must level in the draft is when this happens, you really don't know what will happen of any of the stuff that was in flight. It might get lost, it might go, it might not. Just don't make any assumptions about it. And then maybe there should be perhaps some should level things of something clever you can do. But I think the clever advice, it's going to be hard to decide what the policy is that you want. Like, what would be do the right thing, even if we had all the mechanisms to do it, is very hard to tell. And I don't think this really matters for the users of this. So I sort of lean towards the let's make this as simple as possible. Let's get it done as fast as possible, and basically just say, when you do this, you don't have a lot of control over what happens next.
Right. I mean, the main point is to cancel any kind of to prevent any kind of retransmissions in the end that you're not going to benefit from anyway.
Yeah.
Which in the end saves you some capacity, but you're right. The bets are off on what you're going to get and what you're not going to get.
All bets are off. And if you have access to the stack, which you probably weren't at a low level API, the right thing to do is to try and cancel as much as possible as early as possible, which is probably the default implementation anyway.
David Skenazy, it's me again. I realized that in my previous comment I was being clever, so for that I apologize. That's generally always a bad idea. Jonna made an interesting point to me yesterday in a completely different conversation, that we kind of made a mistake in Quick in that we called these things streams. We should have called them messages.
Mhm.
The mental model that we worked in Quick, and as we were designing it for its initial use case of HTTP3, was like they're messages. Like you're an HTTP request and HTTP response. And the concept of stop sending and reset is, actually this message, this atomic unit of information, I don't care anymore. Or like, I'm trying to send this and like, no, forget it, the whole thing is done. So option B sounds like a much better fit to Quick, like have one media frame per unidirectional stream. I don't think you're getting many benefits from putting two on the same stream. Like, just have them be separate. You'll make your life a lot easier because you'll fit into the Quick model better.
I'd be certainly happy with that as well. We had it before in the draft, and then some discussion arose whether that might be a useful alternative to have to allow for more. But maybe option B is indeed the right thing, because it preserves semantic unity at the same time with the length fields allowing for things to be pre-chopped in case you need to forward them. That doesn't preclude the whole thing to come in multiple pieces, even though it's just one unit. So that would seem to be a sensible solution here. Seeing some thumbs up, even from Colin. All right.
Piers?
I was just going to say, Piers O'Hanlon, that in some ways the sort of putting it over streams is a bit like kind of running conferencing stuff over TCP in some sense, in like you're kind of reliable. So really you want to be aiming for the UDP, the datagram solution within Quick, in that's probably gives you a better match, kind of closer match to the original RTP kind of type distribution. So in some senses, that sort of, I guess this is just like if you can't do the datagrams approach, then you go for the streams. And so presumably the datagrams approach gives you a better approach, mapping anyway, in terms of the original RTP semantics, and that you don't necessarily end up with some junk being sent that you don't want, if that makes sense.
I'm not sure I fully got that.
Okay, all I'm saying is that in some senses sending it over the streams it'd be preferable to be sending it over datagrams, the Quick datagrams, because you wouldn't get this problem.
Right, that is true, but people have been had some interest in doing streams, that there may be sense in having some things reliable because they are iframes or something like that. So that's why this is here. We'll have to dig a bit more about through the technical details of when to use what and how these things fit together. But that's and datagrams are optional in Quick to begin with.
Yeah.
So people have been using streams happily for many in many applications. So it felt wrong to preclude this. Plus, there was also an explicit desire from the working group to actually have that included.
I'm not saying precluding it. I'm just sort of saying in some sense it's just a sort of like.
Of course, it creates
extra
hassles. I think now with B we may have a sensible option or a sensible course of action of dealing with that.
Fine.
So I don't dare to ask the question on the next slide if I want to give Spencer at least 5 minutes for STP. So Magnus? Oh, not even getting there.
Yeah, you're not getting there. I think there's need to be some analysis of what actually puts like limitation of session length with B, if you're gonna go for it as the main. I mean, yes, it's probably each ADU scalability layers are different ADUs maybe. So you're one per sampling, whatever, times a few times. Okay, it's fairly long, but it's not infinite. So I think some analysis of that, etc., what it actually implies and being clear that this actually limits session length compared to normal RTP, which I don't think have the same limitations of any kind of hard stop because this has a hard stop. You're running out of streams, then you must restart the quick connection. You have no other choice when you reach stream identifications up to 62. So yeah.
Yeah, it,
Longer than they'll be alive.
you could always establish a second stream quick connection while the first one is still ongoing, and then migrate over. So I think that's a problem that we can safely leave out. Okay, quickly next slide. So we're not going to get through this now, but the fundamental thing is we have been discussing what scope this draft should be having in terms of multiplexing. And we were advised that depending on which kind of different transport streams one would use, one would need to have different ALPNs. One thought was that we just define this for RTP over QUIC only and don't allow other media types in, so that there is no question on with which congestion control to use, how to prioritize different streams and packets across each other. But then there was also some discussion on whether one should have different multiplexing schemes. And one interesting question that arises from all of this is how one would cope with this multiplexing. Now we have been, and how to demultiplex on the receiver side, and who is going to define the framing or the identification of different logical streams or flows inside, for example, quick datagrams or inside quick streams, and how that would happen, assuming that you might have different applications that would be mapping things to quick datagrams between the same two endpoints. And we originally proposed a session identifier. We discussed a bit whether the usual UDP-based multiplexing could be used, but none of this seemed to be fully satisfactory. So we have been doing some thought experiments. I'm not going to the next slide now. We have been doing some thought experiments whether web transport could be a suitable alternative as a multiplexing scheme, but that seems to have other limitations into which I don't want to go in the interest of time right now, but maybe rather reach out offline to some of the web transport folks to find out what these implications would be. Skip the next slide. That just takes us too long. In the meantime, I updated the first bullet on this side, on this slide for that we probably just document something for S-frame for the MTU size issues. We are looking at further topology considerations, and then next slide to conclude. We need to think more about multiplexing, as I just said. We have had some comments that we need to be more precise in some places, which we are working on. And then we have the usual last concluding bullet, working more with Spencer on SDP signaling, and that's it.
All right. Sorry, Spencer. I'm afraid the other stuff took. I mean, you want to try to talk in 3 minutes?
Thanks much for the feedback.
Yeah.
Thank you for that opportunity, and I will probably take 2. If I could ask you to move next slide. This. So this is what I was talking about with making sure that I understood what the scope of the RTP over quick draft was, figuring out what AVP profiles to register has been easy, because every time I decided what we were going to register, somebody else made another suggestion. So I had the starting proposal was mine, the top line. Then we moved to just doing AVPF. Then we said, I think several of us figured this out at the same time. Oh, we need to prepend UDP to that. Then we said, we need to do stream, dgram, and shared. And then most recently had the conversation a little bit on the mailing list about whether we needed to define TCP, quick, RTP, AVPF to allow TCP ICE path. So this is basically if I do my ICE lookups, can I, and I don't get anything back for Quick, but I do get something back for TCP. Can I use that? And that was the question. I had two questions for the group, which are better on the mailing list anyway. Do people understand that last one? And do people agree? This is why I would like to adopt this draft so that we can make some consensus calls and nail down the scope and a few things like that. If you show the next slide, it will be fun. Because we're also talking about doing quick congestion control. We think we figured out how to do this, and we need to figure out how much RTP information we're going to be able to replace with quick information, and not, I don't mean theoretically, I mean in practice. And that loops back around to what AVP profiles to register. This concludes my abbreviated TED Talk. Thank you for coming, and I will see you all at the interim.
I was just going to say that this just looks like that's the lead. Like, I think there's a ton of things that we need to hit here, like how you identify the flow IDs in the STP that are presumably going to be used, and how you end negotiation of which congestion control you. I mean, like, it seems like when I go and read the RTP over Quick Draft, a ton of the thing that like most of the things that you would need to negotiate to make that draft work, we don't have a way to do in this at all yet. So I think this is barely started. That we should. I think I don't know how we're going to move forward on this, but this is not at all ready to sort of adopt quite yet. I mean, it's missing most of what we need here, so we need to get a bunch of those in. And I apologize for not having sent comments on the list. I will try and send stuff, but yeah. But fair. I just think I should have sent comments, but there's a ton of stuff here we need to figure out how to do, and what the string is at the top is like, yes, that will be a bike shed discussion, but it's the least of the issues.
Yeah. And I had more slides in the presentation, so I'm aware that there's more than one thing to do. So,
all right. So
the last slide started out with requesting that the chairs consider a call for adoption, and now I'm done.
okay. All right, so it sounds like you are not asking for adoption yet, or are you still asking for adoption?
I am requesting adoption. I'm requesting that you all do a call for adoption. That would be progress. Thank you.
Okay. Cullen, apparently Cullen thinks we're not ready yet. So
I guess I don't know if I said that or not. I forget, but I don't think it's ready yet. Is my personal opinion, but do it.
okay. All right. I guess Bernard and I will talk about that, or sadly we did not have enough time to talk about this. So I apologize for that. I should have kept more control over the previous conversation. But we will follow up on the list, and we will have an interim and possibly also a virtual side meeting about SFRAM, which we will also announce on the list. And thank you all for coming, and see you around the meeting.
Well, they mean one every week between now and Yokohama. Oh, yes.
But it's
absolutely.
Two cents on running the I think I don't see it's very hard to do this with one
Yeah.
That's why it has to happen last year. Kind of the same discussion 2 years ago.
Exactly.
About trying to fix it. So I would strongly encourage you guys to have